The question says that a resistance wire connected in a left gap of a meter bridge balances a 10 ohm resistance in the right gap at a point which divides the bridge wire into the ratio of 3 by 2. If the length of the resistance wire is 1.5 meter, then what will be the length of 1 ohm of the resistance wire will be? So the four options is given to us and we have to choose one correct answer. So the solution is given to us. It's showing answer 4. So how it will be answer 4? The figure has been explained very in a good way. Like it has basically given us two resistance, sorry, and one is of 10 ohm and another is X. So we have to find out the X. Okay. So now this is basically, this is length is 1 meter. This one. This whole length is, the whole length of this one is 1 meter and this is 1.5 meter. So 1 meter is equals to 100 centimeter. So after this we can find, now if this is basically hole is 1, so let us take this is L and this would be 100 minus L centimeters. Okay, so we have two ways of solving this question. The first can be X by L is equals to 10 upon 100 minus L. So from this and it will be equal to the ratio that is 3 by 2. So the answer will be getting X would be 15 ohm. And the second way is basically shown here, X into 2 lambda is equal to 10 into 3 lambda. So we'll be getting X is equals to 15 ohm. So now if 15 ohm is basically for 1.5 meter, then what we have to find out for 1 ohm? So how we'll find out? It would be basically 1.5 by 15. So the answer is 1 into 10 raised to power minus 1 meter. That is basically solution number 4. That is option number 4.